Good morning, students. Today we are going to discuss problems on binomial distribution. What we discussed last class, extension of that, we are going to explain here. So let us see that a coin is biased in a way that a head is twice as likely to occur as a tail. If the coin is tossed three times, find the probability of getting two tail and one head. Okay, so here it is. First one, what they mentioned, a coin is biased. So what is the meaning of biased? So here it is, two things we have to know, that biased, unbiased. So biased is nothing but simply we can say that unfair. Okay, so it is unfair. Unbiased is nothing but fair. Okay, so biased is nothing but unfair. It means that it is the probability of getting heads and tails are not equal. Okay, not equal possibility. It means that if you are tossing a coin, so the heads number of times may be more than the tails, or tails may be more than that heads. Okay, the probability of getting heads and tails, so one is more than two, another one, or one is less than two, another one, that is simply will say that biased. So unbiased is nothing but fair. So it means that, so it is having equal possibility. It means that if I tossing a coin, how much probability for getting a head, same that much of probability for tail, that is nothing but unbiased. So this keep in mind these two words. So biased, unbiased. So here it is, biased coin they give, and unbiased is nothing but simply we write fair. Okay, so biased is nothing but unfair, unbiased is nothing but fair. So it means that biased meaning is the probability of getting heads is more than the probability of getting tails, or the probability of getting tails is more than the probability of getting heads. Okay, it means that there is no equal possibility. Okay, it means that simply we can say that if we are taking your class, okay, so if we are taking a particular subject, so if a particular subject, so total strength is 60 and they pass 30 people and fail 30 people, that is nothing but simply what we can say that unbiased. Okay, it means equal possibility. Okay, so what is the pass percentage of that particular paper of that particular class is nothing but 50. Okay, so pass is 50, fail is 50, right? So it means equal. Biased is nothing but, suppose 40 people passed and 20 people failed, or 31 people passed and 31 people, 39 people failed. Okay, that is nothing but simply will say that biased. Okay, so only one thing you have to remember, that biased is nothing but there is no equal possibility. So one is more than that other, or another one is more than the other one. Okay, next unbiased is nothing but equal possibility. So equal possibility means if it is having equal pass for equal pass same, as well as fail for also same thing, that is unbiased. So a coin is biased in a way that, so here that one they are saying, see that head is twice as likely to occur as a tail. So the probability of getting head is twice as likely to occur as a tail. It means that probability of getting heads is nothing but P of H is nothing but equal to twice is nothing but 2 as likely to occur as a tail. So this is the condition they gave in the problem. Here it is, they are saying that the coin is biased. Obviously, there is no equal possibility, one is more than the other. That one they mentioned clearly here. The probability of getting head is twice as likely to occur as a tail. So this one they mentioned in the problem. And next what they mentioned, if the coin is tossed three times, it means number of times a coin is tossed is n is equal 3, and p of x is equal to into p of t, one condition they give, n they give. And what they are asking to calculate, find the probability of getting two tails and one head. Okay, so this is the part, this one we are going to calculate. So probability of getting two tail and one head, so that is nothing but you can calculate p of x is equal to 2 or p of x is equal 1. But the important thing is If we are taking here it is tail is success, then we are going to calculate P of x is equal to 2. And if we are calculating P of x is equal to 1, then we have to choose P as heads. Okay, success is heads. It, already we saw this type of problems also. There it is in 256 sets. Okay, in 256 sets of getting 8 heads and 2 tails. But there the coin is unbiased. So there we got it as P of probability of getting head is 1 by 2, probability of getting tail is 1 by 2. So equal possibility. So unbiased we said. So for that we can calculate P of x is equal to 8 or P of x is equal to 4. There. But here it is we are saying the coin is biased. So if we are calculating P of x is equal to 2, we have to choose P is nothing but this one and we have to choose this as Q. If we are calculating P of x is equal to 1, we have to choose P is this one and Q is this one. Got it? So once again see that what they mentioned in the problem, a coin is biased. It means that whatever the coin we are choosing, that coin is biased. So here biased meaning is nothing but unfair. That is nothing but, okay, there is no equal possibility of getting heads and tails. It means one is more than the other or one is another less than the another. Okay, in a way that so a probability of getting heads is nothing but equal to twice is nothing but 2 as likely to occur as a tail. So P of t. If the coin is tossed 3 times, so how many times we are tossing a coin? 3 times. So for that n is equal 3. Find the probability of getting 2 tail and 1 head. So it means we can calculate P of x is equal to 2 and P of x is equal to 1. Either this one or this one we can calculate. But the very important thing is here the getting of heads and tails are not equal. So for that, if we are calculating P of x is equal to 2, you have to choose P is nothing but this one. If you are calculating this one, we have to choose P as this one. Okay, please take care of that. Very important one. Okay, very important thing here. Okay, in previous problems also we solved this type of one, 8 heads and 4 tails. Okay, but there it is equal possibility. It means unbiased coin there. So for that we used either this one or this one. Why? Because P equal to 1 by 2, Q is also same 1 by 2. But here not like that. Okay. And now go to the solution. Now here it is. So first what we wrote here, what they gave in the problem. So probability of heads is equal to 2 into probability of tail. So this is already they gave in the problem. So that one as is we wrote in the solution. And next we already know that sum of the probabilities is equal to 1. So sum of the probabilities means here only two things. One is heads, another one is tails. So for that we are using here it is P of head plus P of t is equal to 1. So this is only simply we are writing as P plus Q is equal to 1. Okay, so simply we are writing as generally P plus Q is equal to 1. So P representing probability of heads and Q representing probability of tails. Okay, so for that P of heads plus P of T is equal to 1. Then here it is already we know that P of H is equal to 2 into P of T. So that one we are substituting in place of P of H. So in place of P of H we substituted 2 into P of T and we wrote P of T as this. So this is equal to 1. So here it is 2 plus 1 is nothing but 3 into P of T is equal 1. Then P of T is equal, here it is 3 is multiplying, when it comes to this side this is divide. So that's why simply what we can write P of T is equal to, here it is what we are getting 1 by 3. So P of T is equal 1 by 3. So by taking this we can calculate P of H. So it means what we got it Q is equal to 1 by 3 here. Okay. Now next one. Next we are going to calculate P of H by taking this value. Since P of H plus P of T is equal 1. So already we know this. So from this we already calculated P of T. So for that we are taking this one into right hand side. Here it is having plus. When it comes to this side, it changes to minus. So for that, P of H is equal 1 minus P of T. So 1 minus probability of T, we got the value is 1 by 3. So 1 minus 1 by 3. Here 3 is the LCM, and how many times it goes? 3 times. So 1 into 3, 3. So 3 minus 1 by 3. That is 2 by 3. So there it is, what we got it. Number of trials, number of tosses, n is equal to 3 they give. And next one, P of H. So is nothing, P of H we calculated how much we got it, 2 by 3. And next P of T, we got it as 1 by 3. So what we require for applying binomial distribution, n, p, q. Here it is, if you want you can choose p and this is q, or this one p, or this one q, or this one q, or this one p. Now what we are going to choose? So why? Because generally p plus q we are writing is nothing but simply what we will say that P is representing success and Q is representing failure. Okay, so P plus Q is equal to 1. If you are writing that P is success, Q is failure is equal to 1. Okay, that only we are saying. A person who faces the success as well as failure in his life, so that person reaches top position. Okay, so that is only simply here we are saying success plus failure is equal to 1. Okay, so now see that what we are taking success and what we are taking failure here. So let getting a tail is a success. Okay, so getting a tail, what we are taking success. Okay, tail, here it is, we are taking tail as a success. Generally head will choose as success and tail will choose as failure, but here it is we are choosing tail is a success and head is a failure. Okay, it means probability of T this is, and this is probability of H, right? Probability of H and this is probability of T. Okay, so probability of T we are taking as failure. So that is nothing but this is generally Q and this is we are taking as P. Okay, so P plus Q is equal to 1. Okay, so P of T is we are choosing as a P and P of H we are choosing as Q. Okay, now next here this we are applying. So we already know that P is equal to 1 by 3, Q is equal to 2 by 3. It means P of H is equal to 2 by 3 and P of T is equal 1 by 3, we got it. So in place of that simply we are writing as P and Q. So here tail we choose as success. So tail we choose as success, that's why here it is we are choosing this is P of T is equal to 1 by 3 as a success and P of H we are taking as a failure. Okay, so P is equal to 1 by 3 and Q is equal to 2 by 3. So next, by binomial distribution, what we know the formula? P of capital X is equal small x is equal NCX P power x Q power n minus x. So n representing number of trials, x representing success, and this P representing probability of successes. Those successes are x successes, and here it is n minus x failures. Okay, so Q is representing failure. Okay, now here n is equal to 3. Already they mentioned in the problem. Number of tosses n is equal to 3. Here x I am choosing as 2. Okay, so here x we are choosing as 2. Then P of capital X is equal to small x we are going to calculate. So here it is. See that 2 tail. So for that we are calculating tails. Then we have to choose this is as a success. If you are calculating P of X is equal to 1, then you can choose head is a success. Okay, so try to understand. So P of X is equal to 2. X is equal to 2 means 2 tails. So that's why we are choosing tail as a success and head is a failure. Okay, if you are calculating P of X is equal to 1, opposite to that. Okay, so therefore the required probability here it is 3C2 1 by 3 whole square 2 by 3 whole power 1. So this is nothing but NCX. So already what we said the formula NCX P power X Q power n minus X. This is the one we are applying. and here we are calculating P of capital X is equal to 2. So this one we are calculating, right? So in place of n already we know that 3. So that one, that's why we substituted in place of n as 3. Next, in place of x. So in place of x, how much we have? 2. So for that we substituted 2. And p is nothing but 1 by 3, and q is nothing but 2 by 3. And next x is nothing but 2, and n minus x is nothing but 3 minus 2. 3 minus 2 is 1. Okay. Now we are going to calculate 3c2 is nothing but 3. So we are applying, we are getting that NCR. So n factorial y, that is nothing but 3 factorial y 2 factorial into 1 factorial. So n factorial by r factorial n minus r factorial. Okay. So here it is 3 factorial is nothing but 3 into 2 6, 2 factorial is nothing but 2, 1 factorial is 1. So here it is 2 3s are. So then 3ct is nothing but 3, and 1 by 3 whole square 2 by 3. So here is 3 and here 3 cancelled. So 1 by 3 whole square is nothing but 9. So here it is 2. So final answer is 2 by 9. Okay. So this one we can calculate it. P of x is equal to 2. So or if you want you can calculate P of x is equal to 1 also. Nothing will happen. So P of x is equal to 1 also you can calculate. Only the change is here it is 3c1. So 1 is representing here heads. So it will opposite. So this one will get opposite to that. 2 by 3 whole power 1 and 1 by 3 3 minus 1. So that is square. Okay. So that's why clearly we mentioned there we are choosing 2 is nothing but here it is 2 tails. So that's why we are choosing tail as a success. Here 1 is nothing but 1 head. So then we have to choose head is a success. That is P we have to choose as P of head here. Here it is P of t we have to choose as a success. Okay, then obviously we'll get the same thing. So this is equal 2 by 9. Okay, so very important. So here it is. First, what they mentioned in the problem, that one we chosen here it is. So here we got it 2 by 9. So first we chosen here it is. A coin is biased. So again see that biased is nothing but there is no equal possibility of getting heads and tails. Okay, there is no equal possibility. So that's why here they mentioned clearly head is twice as likely to occur as a tail. So it means P of h is equal to into P of t, n they gave. Then we are going to calculate probability of getting 2 tail and 1 head. So that is nothing but, so P of x is equal to 2 or P of x is equal to 1 you can calculate. But the important thing is if you are calculating P of x is equal to 2, you have to choose P of t as a success, P of h as a failure. If you are calculating P of x is equal to 1, then P of h you need to choose as a success, and P of 2 you need to choose. P of t you have to choose as a failure. Okay. Why? Because the coin is biased. Okay. So next topic, binomial frequency distribution. Okay, so that is the problem. Those are the problems on binomial distribution, and here is we are seeing different problems by using the same formula. P of capital X is equal small x is equal NCX P power x Q power n minus x. So here it is already we said the unit is here discrete probability distributions are theoretical distributions. So it means what we said there, theoretical distributions are nothing but frequency distributions. It means already observed frequencies are there in the data. So observed frequencies are there, but we can easily calculate by using these distributions. Either it may be binomial or it may be Poisson distributions. We can easily calculate mean, variance, all those things. Okay, but we may not get the exact values of observed frequencies. We may get nearer to that observed frequencies. Okay, so here it is. See that if n independent trials constitute one experiment. So here it is. We are applying trial is nothing but experiment we are doing, and how many experiments we are doing? n trials we are doing, and those n trials are independent one. It means there is no dependence. Okay, so one trial is independent to another trial. Like as if you are doing your experiments in chemistry lab, you did an experiment, right? So one experiment is different than the other experiment. Okay, one and constitute one experiment. So here they are saying that whatever the experiments you are doing, all those things we can choose as one experiment. And next, this experiment is repeated capital N times. Here it is, small n is representing independent trials, and capital N is representing number of total times. Okay, then the frequency of R successes is n into, simply we write it as probability of x. So n into p of x is equal. So p of, we are saying as generally x. Here it is R, they give R successes. So for that, capital N into p of R. So that is nothing but P of R is nothing but NCR P power R Q power N minus R. So this is the formula we are going to apply. So capital N into P of R, where P of R is nothing but NCR P power R Q power N minus R. There is no change in that. Here it is, capital N is nothing but total number of times, and this is N independent trials, and R represents successes and P represent R successes probability, and n minus R failures of probability. Okay, Q represents. Okay, so capital N into P of R. So generally we are saying X. So X is like in place of R we can substitute X. Okay, but here it is we are saying as discrete distribution. So it means here it is having finite one. So those finite we are taking, since the probabilities of 0, 1, 2 and so on are, and so on n successes in n trials are given by the terms of the binomial expansion of q plus p whole power n. So this is not a new one. So already what we know, that one simply we are writing. So here it is total successes. So there it is, we are saying q plus p whole power n. So by binomial theorem, simply what we can write, q power n plus nc1 q power n minus 1 into p plus nc2 q power n minus 2 p square plus and so on, plus ncn is nothing but 1 plus q power n minus n is nothing but 1 p power n. So this is binomial theorem. Here what we are saying, this is nothing but what it represents, all failures. It means n failures, that is simply we write as all failures, and this is representing, here it is one success. Okay, so p power 1, so one success n minus 1 failures. Next, two successes, three successes, and this is representing n successes. Okay, so if you are taking r successes, so that only here we are saying that, so by using the binomial expansion we will get the properties of successes. This is representing for all failures, and this is representing one success, two success, three success and so on n successes. So therefore in n sets of n trials, the theoretical frequencies are probability frequencies of 0, 1, 2, 3 and so on successes will be given by, so nothing in that. There it is, we are saying as capital N into P of x. In the same way, here it is, when you are calculating frequencies, we have to choose capital N into Q plus P whole power n. So this one you can choose, or capital N into first P of 0, capital N into P of 1, capital N into P of 2, capital N into P of 3. Okay, same we get the same result. Okay, so that only here we are saying. And next, here is the successes will be given by the terms of the expansion of capital N into Q plus P whole power n. Okay, the possible number of successes and their frequencies is called a binomial frequency distribution. So here it is, the possible number of successes is nothing but simply we write x0, 1, 2, and so on, n successes. And next we get the frequencies. So frequencies, how we are calculating? Capital N into q plus p whole power n. So by using this we are calculating frequencies. By these two simply we are calling as binomial frequency distribution. The possible number of successes, these are the possibilities of number of successes and their frequencies. By using this we calculate frequencies. Then we call that is a binomial frequency distribution. So it means that here it is, they give the observations, x they will give, observations they will give, along with that observed frequencies also they give. With that we have to calculate expected frequencies or theoretical frequencies or probability frequencies. These many of things we call those frequencies. Okay, so it means already they give the data, x they give as well as observed frequencies they give. Okay, so we are going to calculate expected frequencies by using capital N into q plus p whole power n. Here n is nothing but number of trials and capital N is nothing but total number of frequency. Okay, so n representing here total number of frequencies and p represents success and q represent failures. Okay, so this is the one we are going to see the problems on this. Okay, next let us see that first one. Fit a binomial distribution to the following frequency distribution. So here it is. It means that they give binomial distribution to the following frequency distribution. It means these are nothing but frequencies. What they give, all these are frequencies they give for different observations. So it means for 0 observation, the frequency observed frequency is 13. For 1 successes, 25 frequency, and next 2 52 frequency, and for 3 58, for 4 32, for 5 16, for 6 4. These are the frequencies they give. Okay, for these observations 0 1 2 3 4 5 6. Now we are going to calculate theoretical frequencies are expected frequencies. Okay, and here it is with a binomial distribution. It means that we are going to calculate expected frequencies, okay, which is nearer to these observed frequencies. Okay, that is the main thing we are learning here, probability distributions. Why we are learning probability distributions? By using the direct frequencies we takes a lot of time. For avoiding that we are using these different distributions. By using these distributions we can easily calculate the frequencies. Okay, now here it is what we require, small n, p and q. So then here it is number of trials. So here n, how many trials they give? 6 trials. 1 2 3 4 5 6. Okay, 0 1 2 3 4 5 6. So number of trials are n is equal 6. Okay, how many? 6 trials. Now we are going to calculate capital N. How we are getting capital N? That is nothing but total frequency. So total frequency is here. How we are getting total frequency? Just by adding all the observed frequencies. That is simply we wrote here summation fi. So summation fi is total observed frequencies. So what are those? 13 plus 25 plus 52 plus 58 plus 32 plus 16 plus 4. So just we added all those things. That is nothing but 200 is the total frequency. It means how we will get the observed frequencies? Capital N into, sorry, how we will get the expected frequencies? Capital N into q plus p whole power n. So here it is, capital N is nothing but 200 and q plus p whole power n is nothing but, here it is, n already we know that 6, capital N we know that, and q and p we are going to calculate. Okay, now we require p and q. So here it is what we are saying, general mean is nothing but what? Summation fi xi by summation fi. So 1 by 200 into summation fi xi. It means we are multiplying the trials along with that observed frequencies. 0 into 13 plus 1 into 25 plus 2 into 52 plus, here it is, 0 into 13 is 0, 1 into 25, 25. Next, 2 into 52, 104. So like that, we need to multiply. Here it is, 3 into 58 plus 4 into 32 plus 5 into 16 plus 6 into 4. And then by adding, we are getting as 535 by 200. So this is equal 2.675. This is actual mean. Okay. Now by using binomial distribution, what we know the mean of the binomial distribution is here. Mu is equal NP. Okay. So mu is equal NP. So this is already they gave. We know that mu is equal NP. But n already we know that number of trials. How many trials? 6 trials. 6p. So by using the above one, so already we calculated actual mean, that is 2.675. And here the binomial distribution mean is 6p. So we are equating those two. Then we are getting as 6p is equal to 2.675. Here it is multiplying when it comes to this side divide. So p is equal 2.675 by 6. How much we got it? 0.446. So p is equal to how much we got it? 0.446. So we can easily calculate q by using p plus q is equal 1, right? So q is equal, simply what we can write, 1 minus p. So 1 minus 0.446, simply how much we got it? 0.554. So now n we know that, since n is equal to 6 from the problem, and p we calculated, and q also we know that. Now we can calculate the expected frequencies. Okay, so here it is. Hence the binomial distribution to be fitted. So it means that we are going to calculate expected frequencies. Okay, now n into q plus p whole power n. So this is the formula we are using. So capital N we already calculated, that is total frequency 200, and q we calculated 0.554, and p we calculated 0.446. Now 200 into, so binomial expansion we are applying, 6e naught, so q power 0 and p power 6 minus 0. So 6e naught, this is q and this is p. Okay, next second one, 6e1, this is q power 1 and p power 6 minus 1. Next 6e2, q square p power n minus x, so 6 minus 2. And in the same way 63 and qp, next 64 q power 4 p power 6 minus 4. In the same way 65 and then q power 5 p power 6 minus 1, 66 this one. So it means just we applied binomial theorem. So if you are confusing this, like writing like this, simply you can use one thing. So here it is, simply you can use capital N into p of x, you can write. So first capital N into p of x, where p of x is equal to what? So p of x is equal what? Nc naught, sorry, ncx p power x q power n minus x, right? So this is p of x. First we can substitute p of 0. So p of 0 is nothing but n, already we know that. N how much? 6 c naught, and p is representing 0.446 whole power 0, and q is nothing but 0.554 whole power 6 minus 0. This is p of 0. In the same way, next p of 1. So p of 1 is equal 6c1 0.446 whole power 1 into 0.55 whole power 4, 6 minus 1. P of 1. Next p of 2. In the same way, p of 2, how can you write? So p of 2 is equal 6c2 6e to 0.446 whole square 0.554 whole power 6 minus 2 like this. So first we can calculate like this. After getting these values, simply you can multiply with n. So n is nothing but 200. So did you get the same as it is or not? Okay. So here it is. What we wrote, same that one. See that 60 naught. 60 naught 0.554 whole power 0 0.446 whole power 6 minus 0. Next this is representing p of 1. Okay, so this is p of 2, p of 3, p of 4, p of 5 and p of 6. After getting, simply you can multiply with 200 each and every term. So after simplifying that, so these are the values we got it. Okay, 0.02891 and next 0.1396. This is nothing but p of 0 and this is value is p of 1 and this is the value of p of 2 and this is the value of p of 3 and this is the value of p of 4 and next this is the value of p of 5 and this is the value of p of 6. So you can calculate separately or like this we can write. So p of 0, p of 1, p of 2, p of 3, p of 4, p of 5 and p of 6. So next we are multiplying each value with 200. By multiplying we got these values. Okay, so capital N into this one. Okay, now here it is. So after multiplying with 200, we got all these values: 5.782, 57.92, 56.18. These values. Now we have to write the observed frequencies. Sorry, expected frequencies. The successive terms in the expansion gives the expected or theoretical frequencies. It means whatever we calculated, these things we call it as a expected frequencies. Now we have to write here. So x values already they gave in the problem and these are the frequencies which are observed frequencies what they mentioned in the problem. And here it is expected frequencies. It means from this we are writing. So first one 5.782. So it means what we can write here it is 5.782. Frequencies always must be integers, not decimals. Okay, so it means 6 and this is 27.92. So this is simply what we can write 28. After decimal 0.5 above, simply we are round up that. And 56.18, simply what we can write, this is 56. And next 60.32, simply what we can write is 60. And next 36.42, so this is 36. And next 11.728, that is simply we can write 12. And this is 1.57, so this is 2 we can write, or 1.5 something 1 2. Okay, so these are the we got it as expected frequencies. That only here we are going to write. See that 6, 28, 56, 60, 36, 12, 2. Why? Because frequencies always must be integers. So we have a round of that. If it is 0.5 above, next digit. Okay. So which are nearer to that or not? Okay. So here it is 32, 36. Okay. 58, 60, 52, 56, 25, 28. Okay. So like this. Okay. Why we are using binomial distributions and our theoretical distributions or probability distributions are nothing but for calculating expected frequencies. Okay, so this is procedure. Okay, so here it is. Once you see that, first we have to be calculated PDF binomial distribution for the following frequency distribution means we are going to calculate expected frequencies. First, small n we have to write number of trials are here: 0 trial, 1 trial, 2 trial, 3 trial, 4 trial, 5 trial, 6 trial. So n is equal to 6 trials. And capital N we are going to calculate. So capital N is nothing but total frequency. So total frequency, just we have to add all those values. We got it as 200. Next, we are going to calculate P and Q. So for that, first we are using mean. So general mean. So summation Fi xi by summation Fi. So summation Fi is nothing but how much? 200. So 1 by 200 into frequencies and number of trials. So we are multiplying that. So 0 into F1, 0 into 13. Next 1 into 25. So 2 into 52 plus 3 into 58 plus 4 into 32 plus 5 into 16 plus 6 into 4, 24. Okay. Now simply we got it as 2.675. Next we are going to calculate now actual mean, we know that. So what about that? NP. So this is equal 6p. By using this one equation 1 and equation 2, 6p is equal 2.675. From that we got the values p, and next we calculated. And the binomial distribution to be fitted is n into q plus p whole power n. So 200 into this one. So like this we can use, or first you can use binomial expansion. P of x formula uses it. Then you have to find p of 0, p of 1, p of 2, p of 3, p of 4, p of 5 and p of 6. After getting those values, simply you can multiply with 200. Okay, then you get capital expected frequencies. Okay, so the expected frequencies are close to observed frequencies, a measure of closeness called goodness of fit. Okay, so it means we are going to calculate expected frequencies. If suppose if you are getting which are nearer to observed frequencies, okay, it means that actual result something is there. Okay, when you are doing experiment also. Okay, so if you are doing any chemical experiment, so actually some result will be there. After doing the experiment, you'll get some result. Okay, if it is matches to that, okay, so exact result is match ayindante, then we'll say that simply you are you did very well. So with accurate values, with accurate values you did everything, that's why you got it exact result. In the same way here it is, if you are getting expected frequencies which are very close to observed frequencies, then we say that that is goodness of fit. Okay, so next column, this is the last one for binomial distribution. Okay, 4 coins are tossed 160 times. It means number of trials here it is 4. The number of times x heads occur is given below. It means 0 heads how many times came? 8 times. 1 head 34. 2 heads 69. 3 heads 43. 4 heads 6 times. Okay. So fit a binomial distribution to this data on the hypothesis that coins are unbiased. Okay, so unbiased, just now we explained. So unbiased is nothing but equal possibility. Okay, if you are tossing a coin, how much possibility for heads? Same that much of possibility for tail. So this is unbiased is nothing but equal possibilities for heads as well as tails. So first one simply we wrote the coin is unbiased. So for that simply what we are writing, P is equal 1 by 2, Q is equal 1 by 2, and already they give number of trials, N is equal to how much? 4. So for that here it is simply we wrote P is equal to 1 by 2, Q is equal to 1 by 2 and N is equal to 4. So directly. Okay, and next P we know that, Q we know that, N we know that. Then what we require? Capital N we require. Or we are getting capital N. So capital N nothing but sum of all these frequencies, right? 8 plus 34 plus 69 plus 43 plus 6. Of course that one also they mentioned in the problem. So number of times, how many times? 160 times. That is capital N. So if you want you can check it just by adding all those values. Simply we use this one or not. So capital N is equal sum of all the frequencies. By adding sum of all those frequencies, what they mentioned in the problem, we got it as 160. So N we know that, small n we know that, P we know that, and Q we know that. Okay. So then we are going to calculate expected frequencies. Okay. So here it is. P of x is nothing but what? By binomial distribution, simply we can write P of x is equal ncx p power x q power n minus x. Okay, here we are using recurrence relation. Okay, recurrence relation of binomial distribution. So in some of the cases they may mention use recurrence relation. Okay, so otherwise same like as previous one, you can solve this one also. Okay, nothing will happen. If they mention specifically use recurrence relation, then we can use this formula and then we can calculate. Okay, so here it is. What is meant by recurrence relation is nothing but recurrence relation is a general relation which is used for calculate different values. Okay, so like as p of 1, p of 2, p of 3 and so on, p of n. Okay, so like that we can calculate. That's why simply we call that is a recurrence relation. Okay, so here it is. P of x plus 1 is equal p of x n minus x into p by is to p of x. So this is recurrence relation, we call it as here. We know the value of p and we know the value of q and we know the value of n. So n is equal to how much? Number of tracks 4 and p is equal to how much? 1 by 2 since the coin is unbiased, and q is equal to how much? 1 by 2. P equal to 1 by 2, Q is equal to 1 by 2, right? So P by Q means what we'll get? So P by Q is nothing but 1 by 2 by 1 by 2. So 1 by 2 by 1 by 2. So is equal to how much? 1. So this one both will cancel. So that's why simply here we wrote P by Q is equal to 1. And already they gave in the problem a number of trials n is equal to 4. So now we are substituting in place of n and P by Q as 1, and this is the remaining one. So Q of x plus 1 is equal n minus 4 minus x by x plus 1 into p of x. What about p of x? So p of x is nothing but what? So ncx p power x q power n minus x. This is p of x. So ncx p power x q power n minus x. So p first we are substituting in place of x as, so first we are calculating this is in place of x as 0. So p of capital X is equal small x is equal ncx p power x q power n minus x. So 4c naught. So n in place of n 4 and in place of p 1 by 2 and in place of q 1 by 2. So those things we substituted here. 4c naught in place of p 1 by 2 and in place of q 1 by 2. This is p power 0 and 4 minus 0 is nothing but 4. So simply how much we got it here? 4c naught is nothing but 1. Anything power 0 is 1. So 1 by 2 whole power 4 is nothing but 1 by 16. This is p of 0. Okay. Now we are going to use recurrence relation for getting remaining values. Here it is. If you see that, what is the formula? P of x plus 1. Okay. Now we have to substitute in place of x as 0. So if you substitute 0, what we'll get? So here it is. If you substitute 0, p of 1 is equal, p of 1 is equal simply 4 minus, in place of x we are substituting 0. 4 minus 0 is nothing but 4 and 1 plus 0 plus 1 is 1. So this is 1 and next p of 0. So this is equal 4 into p of 0 just we calculated. How much we got it? 1 by 16. So that is nothing but, here it is 4 times. So that is simply what we got it. P of 1 is equal 1 by 4. Okay. Next p of 2 we require. So for that what we have to substitute? In place of x as 1. So 1 plus 1 is 2. So p of 2 is equal. So what we'll get? So 4 minus, in place of x how much we are taking? 1. So for that 4 minus 1 by 1 plus 1 into p of 1. So this is equal, 4 minus 1 is 3 by 2 into p of 1. So p of 1 is how much? 1 by 4, right? So this is equal to how much we are getting? 3 by 4 into 2, 8. So this is p of 2. Next we have to substitute in place of x as 2. Then we get p of 3. Next p of 4. So like that we can calculate. Okay. So what we did previous problem, same as it is, like that we can solve. Okay. Here simply what we are using, recurrence relation we are using. In some of the cases they may ask just to use recurrence relation and fit a binomial distribution. In that case we have to use that formula. Otherwise, simply how we solved previous one, same like that you can solve. Okay. So let us see that those values we got it or not. Here it is. See, number of weights, this is they already they gave in the problem. And next, observed frequencies. This one also already they gave in the problem. So 8, 34, 69, 43, 6. And next, first one, P of 0 we calculated, right? So how we got it? We got the value is 1 by 16. And P of 1 we calculated 1 by 4. And P of 2 we calculated 3 by 8. And P of 3 1 by 4. And P of 4 1 by 16. Next, expected frequency is nothing but simply what we are doing, capital N into P of X. So capital N, how much we got it? 160. So for that, 160 into 1 by 16. 160 into 1 by 4. So 160 into 3 by 8. 160 into 1 by 4. And 160 into 1 by 16. So these are the expected frequencies. How much we got it? 10, 40, 60, 40 and 10. So these are the expected frequencies. So here observed frequency is 8 and expected frequency is 10. Observed frequency is 34 and this is 40. 69, 60 and next 43 and next 40 we got it here and 6, 10. So these are the observed frequencies and these are the expected frequencies. Okay. So now simply we write that one as this what they mentioned. Okay. Same previous problem also you can construct like that. Then this looking nice. Okay. P of x, first you can calculate all these probabilities. So simply here it is we use recurrence relation or simply what we are using, P of x is equal NCx P power x q power n minus x. This is P of x. First we can substitute 0 in place of x. Next 1, 2, 3, 4. N already we know that 4 and P already know that 1 by 2 and Q also we know that 1 by 2. Simply we substitute and we get all these values. After getting, you need to multiply with capital N. Then we get all these observed frequencies and expected frequencies. Of course, observed already they mentioned. So that is simply we can write if you want. And finally, x observed frequencies and expected frequencies. That one we can write simply here. Okay. So this is frequencies. So these are the problems on binomial distributions. So fitting a binomial distribution. So and previous problems. Okay. Thank you.